In this video, I'm going to show you how to decide which of the 5 reasons we can use to prove that two triangles are congruent. But first of all, let's come off to the side and review those 5 reasons. They are SSS, which stands for side, 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 SAS, side, angle, side, ASA, angle, side, angle, AAS, which is angle, angle, side, and finally HL, which is hypotenuse, leg. These are the only 5 reasons that we can use to prove that two triangles are congruent. In addition to these 5, I want to point out 2 letter combinations that do not prove triangles are congruent. The first one is AAA. All right, having 3 pairs of congruent angles does not prove that two triangles are congruent. So if we see that, we will say triangles cannot be proven congruent. And the other one is SSA. All right, if we see this set of information, the triangles cannot be proven congruent. So there's one thing I need to point out to you right at the beginning. When you look at these two, for example, ASA versus AAS, both of these involve 2 angles and a side. 2 angles and a side. So what's the difference? The difference is that for ASA, the side is between the 2 angles. So I'm just going to put between right here. And for AAS, the side is not between. All right, I'm just going to put not. And again, I want you to use that same thought process to differentiate between SAS and SSA. So both of these involve 2 sides and an angle. 2 sides and an angle. And again, the way you will know the difference is for SAS, the angle is going to be between the 2 sides. Whereas for SSA, the angle is not between the 2 sides. All right, so just keep that in mind as we go through. So a couple of examples will clear this up. So when we look at problem number 1, before we can really get started, there's an additional piece of information that we can mark just based on the way the picture is drawn. So we see that we have 2 congruent angles, all right? They're both right angles, and we see that these 2 sides are marked congruent. But also the shared side is automatically congruent. It's the same segment for both triangles, so you should go ahead and mark that. So with that in mind, if you focus your eyes on one of the 2 triangles to decide which rule we're going to use, so I'm going to focus my eyes on this triangle. So I see that we have 2 sides and an angle. Actually, because this is a right triangle, the first thing we're going to do is ask ourselves, will this be hypotenuse leg? Because hypotenuse leg is for right triangles only. Now that doesn't mean that when you see a right triangle it will automatically be hypotenuse leg, but that's the first thing you should check. The hypotenuse is always right across from the 90-degree angle, so this shared side is the hypotenuse. Any other side of the triangle is a leg, so this side over here is a leg. So we have a hypotenuse and a leg marked congruent. So these triangles will be congruent by hypotenuse leg. Let's slide over to problem number 2. Let's go ahead and mark the shared side as being automatically congruent. Now focus your eyes on one triangle at a time. So let's just look at the yellow triangle. So looking at the yellow triangle, I see that we have two sides and an angle marked congruent. All right, two sides and an angle. So that means this is either going to be SSA, which remember, if that's the case, SSA does not prove triangles are congruent. So if it turns out to be SSA, I'm going to pick this one. But it might also be SAS, okay, side, angle, side. And again, the difference between those two is whether or not the angle is between the two sides. If the angle is between the two sides, then it's SAS. So let's see. Let's really focus on the two sides we have. So here's one side that is marked congruent. And here is the other side that is marked congruent. Now, look at the spot where they meet. This is the angle that is between those two sides. Is that the angle that was marked congruent? No. So the angle that is marked congruent is not between the two sides. Okay? And when the angle is not between the two sides, that's side-side angle. So this is the side-side angle situation, which means that the triangles cannot be proven congruent. By the way, do not write SSA on this line. That is not one of the things that proves triangles are congruent. It's not really a thing. So just leave it blank and circle triangles cannot be proven congruent. Look at problem number 3. Let's go ahead and mark the shared side as being congruent. So we are given an additional piece of information right here. Segment BC bisects angle ABD. All right, so angle ABD, let's focus on that for a moment. Here is angle ABD. Bisect means to cut in half. So the shared side bisects angle ABD. It cuts it in half. So that means that this side is going to be congruent to this side of the angle. All right, now let's take a step back and focus on one triangle at a time. So let's go ahead and focus on this triangle for right now. What do we have? I see that we have two sides and an angle. Two sides and an angle. So again, this is either going to be SSA, which is not a thing, which means triangles cannot be proven congruent, or it will be SAS. And it all comes down to whether or not the angle is between the two sides. So let's trace it out. Here is one side right here. That's one side that's marked congruent. And here is the other side that's marked congruent. So where do they meet? Those two angles meet right here. So this is the angle that is between the two sides. Is that the angle that is marked congruent? Yes, it is. So because the angle is between the two sides, that makes this a side angle side situation. So the triangles can be proven congruent by side angle side. Look at problem number 4. Let's go ahead and mark the shared sides as being congruent. Look at the additional piece of information. Segment BC bisects angle ACD. Well, here is angle ACD down here, all right, not a very straight line, but you get the idea. So bisect means to cut in half. So that means that this side of the angle is congruent to this side of the angle. All right, let's focus on one triangle at a time. So let's focus on this yellow triangle right here. So what do we have? All right, once again, we have two sides and an angle. So this is either a side-side, whoops. This is either a side-side angle situation or a side angle side situation. Both of these involve two sides and an angle. Remember that side-side angle does not prove that triangles are congruent. So if it turns out to be this, we will choose this and leave the line blank. The difference all depends on whether or not the angle is between the two sides. So let's trace it out. Here is one of the sides that is marked congruent. And here is the other side that is marked congruent. All right, look where these two sides meet. They meet right here. So this is the angle that is between the two sides. Is that the angle that is marked congruent? No, the angle marked congruent is way over here. So the angle is not between the two sides. So that makes this a side-side angle situation, which means that the triangles cannot be proven congruent. Leave this blank. All right, let's jump down to problem number 5. So for this problem, there is an additional piece of information that we can mark just by the way that the picture is drawn. There's no shared side, but angles like this are called vertical angles. All right, see this X that's being formed right here? When you have intersecting lines, they form vertical angles right across from each other. And vertical angles are always congruent. So go ahead and mark those congruent whenever you see them. Now focus on one triangle at a time. So focus on this yellow triangle, for example. What do we have? I see that we have two angles and a side marked congruent. So this will either be angle, angle, side, or it will be angle, side, angle. Both of these involve two angles and a side. The difference all depends on whether or not the side is between the two angles. If the side is between the two angles, it will be angle, side, angle. Otherwise, it will be angle, angle, side. So let's trace it out and see. Okay, here is one of the angles that is marked congruent, and here is the other angle that's marked congruent. The side between those two angles will be the segment connecting these two vertices. So this is the side between those two angles. Is this the side that is marked congruent? Yes, it is. So that means the side is between the two angles. So we're going to recognize this as angle, side, angle. So yes, the triangles can be proven congruent by angle, side, angle. All right, looking at problem number 6, again, let's go ahead and mark these vertical angles as congruent and focus your eyes on one triangle at a time. All right, for example, let's look at this yellow triangle right here. What information do we have? I see that we have two angles and a side just like before. Okay, so I have two angles and a side. So it'll either be angle, angle, side, or it will be angle, side, angle. It's going to be one of these two things. The question is the side between the two angles? That would make it angle, side, angle. All right, well, here is one angle that's marked congruent. Here's the other angle. If you connect those vertices, that is the side that's between. Is that the side that is marked congruent? Yes, it is. So the side is between the two angles. That makes this an angle-side angle situation. So the triangles can be proven congruent by angle-side angle. Okay, look at problem number 7. Let's go ahead and mark the vertical angles as being congruent, like we did before. Now we have this additional piece of information. C is the midpoint of BE. All right, C is the midpoint, but you really have to focus on the fact that we're talking about BE. So C is the midpoint, but that means that this side is congruent to this side. Segment BC is congruent to segment CE. So it matters what C is the midpoint of. So this is the information that we have. Now, in terms of sides and angles, if you focus on one triangle at a time, you can start to think about what set of information we are given. So I see that we have two angles and a side. So this is looking pretty familiar. We have two angles and a side. So this is either going to be angle, angle, side, or angle, side, angle, depending on whether or not the side is between the two angles. So here's one angle that's marked. Here's the other angle. If I connect those dots, this is the side between. Is that the side that is marked? It is. So the side is between the two angles. That makes this angle, side, angle. So the triangles are congruent by angle, side, angle. Let's glance at problem number 8. Go ahead and mark the vertical angles congruent. What other information are we given? C is the midpoint of AD. Notice that this last part is significant. This time, C is the midpoint of AD, which is right here. That means that AC is congruent to CD. Let's go ahead and focus on one triangle at a time. For example, let's focus on this triangle in yellow. What information do we have? I see that we have two angles and a side, just like before. So this is either going to be angle, angle, side, or it will be angle, side, angle. It all depends on whether or not the side is between the two angles. Well, here's one angle that's marked congruent. Here is the other angle. If I connect those vertices, this is the side that is between the two angles. Is that the side that's marked congruent? No. The congruent side is way over here. It is not between the two angles. So that makes this angle, angle, side, because the side is not between the two angles. So the triangles are congruent by angle, angle, side. All right, what about problem number 9? We're back to the shared side situation, so let's go ahead and mark these as being congruent. In addition to that, we are given that segment BC bisects angle ABD. Focus on this for a minute. Angle ABD is this right here, ABD. So if CB bisects that angle, bisect means cut in half. So that means that this part will be congruent to that part. All right, now focus on one triangle at a time. So I'm just going to arbitrarily choose this triangle to focus my eyes on. what information are we given? I see that we are given two sides and an angle. So that means this will either be side-side angle, which is not a thing and does not prove triangles are congruent, or it will be side, angle, side. Both of these involve two sides and an angle. The difference is whether or not the angle is between the two sides. So let's trace and see. So here is one side that's marked congruent, and here is the other side that is marked congruent. Where do they meet? Those sides meet right here. Is that the angle that is marked congruent? Yes, it is. That means the angle is between the two sides. So that makes this a side angle side situation. All right, let's slide over to problem number 10. Go ahead and mark the shared sides as congruent. In addition to that, we are given segment BC bisects angle ABD. So angle ABD is this angle on the outside. Okay, this is angle ABD. Bisect means to cut in half, so that means that this side is going to be congruent to this side. All right, let's back up and see what we have. Focus your eyes on one triangle at a time. So let's look at this triangle for now. What do we have? I see that we have two angles and a side. So this is either going to be angle, angle, side, or it will be angle, side, angle. The difference is whether or not the side is between the two angles. So let's see. Here's one angle, here's the other angle. This would be the side that is between those two angles. Is that the side that is marked congruent? No, the congruent side is way over here. Because the side is not between the two angles, that makes this an angle, angle, side situation. So the triangles are congruent by angle, angle, side. Okay, look at problem number 11. Go ahead and mark the shared side as congruent. What else do we have? We are given that BC bisects angle ACD. All right, ACD goes from A to C to D. Bisect means cut in half, so that means that this side is congruent to this side. So let's back up and look at one triangle at a time. So focus on this yellow triangle, for example. What information do we have? I see that we have two sides and an angle. So this is either going to be side, side, angle, which does not prove triangles are congruent. So if this is the case, I'm going to circle this. Or maybe it is side, angle, side. Another way of having two sides and an angle. The difference is whether or not the angle is between the two sides. So it helps sometimes to trace the sides to see. So here's one side, and here is the other side. Okay, where do they meet? They meet right here at angle B. Is that the angle that's marked congruent? No, the congruent angle is way over here. So the angle is not between the two sides. All right, so when the angle is not between the two sides, it is a side-side angle situation. Do not write that on this line. Side-side angle does not prove triangles are congruent, so You cannot write it on that line. Instead, just circle this.
For number 12, let's start off by marking the shared side. So this will be congruent for both triangles, of course. But in addition to that, we are given that segment BC bisects angle ACD. So where is angle ACD? It's right here. Remember, bisect means to cut in half. So that means that this side is congruent to this side. So focus on one triangle at a time. So for example, let's focus on this yellow triangle. What type of information do we have? I see that we have two angles. I should double mark this. I see that we have two angles and a side. So that means we are either dealing with angle, angle, side, or angle, side, angle. It all depends on whether or not the side is between the two angles. Well, here's one angle that's marked. Here's the other angle that's marked. So this is the side that is between the two angles. Is that the side that is marked? No. The marked side is way over here. So the side is not between the two angles. So that means we have an angle-angle side situation. All right, let's take a look at problem number 13. Let's start off by marking the shared side congruent. We are also told that AD is perpendicular to BC. So AD is perpendicular to BC. That means that we have a right angle here in the corners. So we have two right angles. Let's focus on one triangle at a time. So let's focus on this triangle right here. What type of information do we have? I see that we have two angles and a side. Well, first of all, because of the right angle, I should ask myself, is it hypotenuse leg? Well, remember that the hypotenuse is the side that is across from the 90-degree angle. And the hypotenuse is not marked. So this cannot be hypotenuse leg. So instead, we'll just look at this as any regular triangle. So we have two angles and a side. So this is either going to be angle, angle, side, or it will be angle, side, angle. It all depends on whether or not the side is between the two angles. So here are the two angles. There's one here and there's one here. This is the side that runs between the two angles. Is that the side that was marked? No. The congruent side is over here, not between the two angles. So that tells us that we have an angle-angle side situation where the side is not between the two angles. All right, let's slide over and look at number 14. Start by marking the shared side congruent. We are given that AD is perpendicular to BC. So again, that means that we have right angles here and here. So focus on one triangle at a time. Okay, like this. Again, because I'm looking at a right triangle, I should ask myself, is this hypotenuse leg? I always ask myself that first. But the hypotenuse, which would be here, is unmarked, which means it can't be hypotenuse leg. So looking at this as a regular triangle, I see that I have two angles and a side. So I have two angles and a side, which means either angle, angle, side, or angle, side, angle. It all depends on whether or not the side is between the two angles. Here is one angle that's marked. Here's the other angle. Here is the side between those two angles. Is that the side that is marked? Yes, it is. The congruent side is between the two angles. That means this is angle, side, angle. Okay, let's do two more problems. This time, there is no shared side. Even though this portion overlaps, it's not the full side of the triangle. So we cannot mark these sides congruent because they're not the same length. Well, what can I do? We are told that AE is perpendicular to BC. So here's AE, and here's BC. So if those are perpendicular, that means we have a right angle here and here. All right, because of the right angles, we should quickly ask ourselves, do we have hypotenuse leg? Okay, let's focus on one triangle at a time. So I'm just going to pick this triangle over here. So, is this hypotenuse leg? Well, this is the hypotenuse across from the right angle, and it is marked. So we have hypotenuse so far. What about leg? Any other side of the triangle would be a leg. But that's the only side we had, right? This side over here is unmarked. This side over here is unmarked. So we have hypotenuse, but not leg. So it cannot be hypotenuse leg. So we have to treat this as a regular triangle. So I see that we have two angles and a side. So this is either going to be angle, angle, side, or it will be angle, side, angle. It all depends on whether or not the side is between the two angles. So here's one angle that's marked. Here's the other angle that's marked. Here is the side that's between the two angles. Is that the side that is marked congruent? No, the congruent side is way over here, not between the two angles. So because the side is not between the two angles, that means this is an angle, angle, side situation. Last one. So be careful, because remember, there is no shared side here. For the one triangle, this side is long, like this. For the other triangle, this side is short. So these are not the same. So we cannot mark these congruent. Instead, it almost might be best to draw these triangles separately. So that's what I'm going to do. I'm going to take the extra step and draw these triangles separately so you can really see what's happening here. Okay, so we have this triangle on the left that looks like this. All right, so I'm gonna, I took the colors with it. That's fine. So this is triangle A, B, C. Okay, and we have this marked and we have this marked. Okay, we do not have side CB marked, because this little mark is for the other triangle. So I'm going to go ahead and draw that triangle now. Okay, so here is the other triangle. And this is triangle BDE. So can you see that this mark right here is really for this triangle? Okay, because it represents the entire side. And we also have a mark here. That's not enough information yet. But we're also given that AE is perpendicular to BC. So again, here's AE and here is BC. So that tells us that we have right angles here and here. So translating into our picture, that means I have a right angle here and a right angle here. So now we can do the problem. These are right triangles, so I should stop and ask myself, is this going to be hypotenuse leg? Well, let's go ahead and focus on one triangle at a time again, and let's focus on this triangle. Okay, I wonder, can I erase this blue? All right, let's focus on this triangle. Do I have the hypotenuse? Yes, the hypotenuse is across from the 90-degree angle and it is marked. Do I have a leg? Yes, any other side of the right triangle will be a leg. So we have a hypotenuse and a leg congruent to hypotenuse and the leg. So this is, in fact, hypotenuse leg.